Okay, now here's a question which we're going to solve. Let's see what it says. Just a minute before we start. Sir, if you could show how. I did yesterday. Yesterday I gave a whole. I'll do it again today, not a problem. But yesterday we discussed how we do it. Do you have this calculator, Shaihan? Casio ClassWiz?
Yes, sir.
Okay,
Yes, sir.
brilliant. Okay, so we'll learn again today. Okay, I'll teach you guys again how to do it. Just a minute. Okay, now let's start. So it's a fairly recent question. It's May, June 2022, paper 1, variant 1. Okay, question number 5. And notice how many marks it is? 5 plus 4, 9, 9 plus 2, 11. So that's almost 20% of your paper. Okay, let's see what it says. And it's not all just normal distribution. In between, you might have conversion as well. Okay, or maybe if not conversion, then something similar to it. Let's see. Okay, let's see. So the question says the lengths in centimeters of the leaves of a particular type are modeled by the normal distribution 5.2, 1.5 squared. Find the probability that a randomly chosen leaf of this type has length less than 6 centimeters. So that means X is normally distributed with mean 5.2 and variance 1.5 squared. And we have to find out in the first part the probability that X is less than 6. Okay. So first thing we have to do is we have to find out the z-score of 6. That means x 6 minus 5.2 over 1.5. Remember, it's always divided by the square root of the variance, which is the standard deviation. So this means that 6 minus 5.2 divided by 1.5. Okay, so we're looking at 0.5333. So z is equals to 0.5333. Okay, although 3 decimal places are enough. So now we have to find out the probability of z being less than 0.5333. Okay, so what are we going to do? We are going to refer to the z table. Okay, and when it's less than, do we subtract it from 1? True or false? If it's less than, do we subtract it from 1? Yes or no?
No, sir.
No, we don't. Okay, so 0.533. So 0.5 is right here, 0.53 is right here, 0.7019, and then in the end we're going to add 10 to it. So 0.7019 plus 10. Acha, let's use the calculator over here. Okay, let's use the calculator over here. Now remember, you can use your calculator for two purposes. You can use your calculator to find the z-score, or you can use your calculator to find the final answer, the probability as well. Okay. So if you want to use your calculator to find out the probability, if you want to use your calculator to find out the value of p, in that case you take the mean that's given in the question and you take the variance as given in the question. Okay, but if you want to find out the z-score, okay, that means if you want to find out the probability using the z-score, in that case what you do is, if you're using the value of z, which is 0.533, okay, in that case the mean that you're going to use is 0 and the standard deviation that you're going to use is 1. Okay, so keep that in mind. So if you're using the value of x, okay, if you're using the value of x, then you use the mean of x and the standard deviation of x as well. Okay, so use your calculator, see what answer you get, so that I can make sure that you understood or you've learned how to use it. Normal cumulative distribution. Lower is going to be a very negative value, upper is going to be 6, 1.5, the standard deviation, mean 5.2. 0.703 is correct. Okay, so that means the probability is equal to 0.703. Acha, I had to teach you guys how to do it. So here's what we're going to do. press menu and see where you navigate to where you see distribution. Okay, you'll see a bell curve. Okay, where do you see it? You see it at 7. And then after you press that, what we want is normal cumulative distribution, which we have at number 2. Okay. Then the calculator wants you to enter the lower value, the upper value, the mean, and the standard deviation and the mean in that order. Okay. Now the lower value, since its x is less than 6, there is no lower value as such. Okay. So what we're going to do is we're going to enter an extremely negative value. Okay, because we don't know what the range is. We're not going to write 0. Okay, keep that in mind. We're just going to enter an extremely negative value, ideally minus 10,000. Okay, so minus 10,000. Then the upper value, since the upper limit is 6, so we'll write 6 in place of upper. Okay, then what's this symbol? This symbol, if you look closely, is sigma, which is basically for standard deviation. Okay, remember we're using values of x, so we'll write down the mean and standard deviation of x only. So that's 1.5, and the mean of x is 5.2. Press the equals to sign, press the equals to sign again, and now you have the probability, which is 0.703. Okay, so this is how you use it. Alright, now that's the first part. You get 2 marks, 2 easy marks. Any questions? If yes, feel free to ask. Okay, part B says find, there's a whole lot of information before that. The lengths of leaves of another type are also modeled by a normal distribution. The scientist measures a random sample of 500 leaves and of this type and finds that 46 are less than 3 centimeter long and 95 are more than 8 centimeter long. Find estimates for the mean and the standard deviation of the leaves of this type. Okay, how do we do part B? How do we do part B? Any idea? Okay, how many unknowns do we have? So let me make it easy for you guys. It's a 5-mark question. How many unknowns do we have? Yes, we will have to take inverse. Okay, why? Because we have 2 unknowns. Okay, we have not, that's not the reason why we will have 2 unknowns. That's not the reason why we have to solve it simultaneously. The reason why we'll have to solve it simultaneously is because we have 2 unknowns. We have to find out the mean and the standard deviation. Okay, so these questions are, it's easy to set up the equation, but solving them can be a pain. Okay, why? Because you have so many decimals that you're dealing with all the time. Okay, so just be patient. Don't lose your focus. Don't lose your temperament. Okay, very important. Okay, so let's write the information down. So we're talking about 500 leaves of this type and finds that 46 are less than 3 centimeter long. That means the probability that x is less than 3 is equal to what? Is equal to 46 upon 500. Okay, is equal to 46 upon 500. And the probability less than 3 centimeter long and 95 are more than 8 centimeters long. That means the probability that x is greater than 8 centimeter is equal to 95 over 500. Okay, so I hope you guys are following. Let's convert this in decimal. 46 divided by 500, so that's equal to 0.092. 0.092. Okay, and let's convert this into decimal. 95 divided by 500, that's 0.19. Okay, so the probability of x being less than 3 is 0.092 and the probability of x being greater than 8 is 0.19. Okay, that's a good question. I haven't looked into that, Rabia. I'm gonna have to look into it. I'm sure you can. There is an option to take inverse normal. Yes, you can. 0.092. Yeah, you can. Okay. Yes, you can. I just learned. So first, let's do it without a calculator, and then I'll show you how you can do it using your calculator as well. Okay. Once again, I only know how to do it in this. The other calculators, I'm not too sure. Okay. So if you had to find out the z-score of 3, how would you do that? You would do it like this: 3 minus the mean upon sigma. That would give you the z-score. Okay, this is what z would be equal to. So that means the probability of z being less than 3 minus mu over sigma is equal to 0.092. Okay, is equal to 0.092. Okay, Now, what happens when you take, and basically how would we have worked out phi of this? We wouldn't have subtracted it from 1. Phi of this would have been the final answer. Okay, so that means phi of 3 minus mu over sigma is equals to 0.092. Okay, now let's not take inverse using a calculator. First, let's do it with the help of a table. Now, do I have values that are less? Will I find 0.092 in the table? Will I find a probability of 0.092 in the table? Yes or no? No, I won't. So what do we do in that case? Okay, we will have to take phi inverse of 0.092, right? But how do I do that now? Yes, that's correct. So we subtract this from 1 and we multiply the left hand side by minus. Okay, or you multiply it by minus. All right. So basically 3 minus mu over sigma means taking the phi inverse of 0.092. Now, since it's not possible, so we do 1 minus 0.092, which gives us 0.908, and we take this with a minus sign, 0.908. Okay. Now, let's see what the phi inverse of 0.908 is, and then I'll teach you how to do it using a calculator as well. So, phi inverse of 0.908. So 908, 9599, 908, 908, 908. Okay, so we have 9082, we have 9066. Okay, so what should I add in 9066 in order to make it 908? We should add 14. Okay, now let's see if we can do that. Let's see if we can do that. So here's 0.9066 and here's 14. Okay, so 1.329, 1.329. Yep, that's correct. Good job. 1.329 is the correct answer. So now we finally have one equation sorted, which is, let me make some room here. 3 minus mu upon sigma is equal to minus 1.329. Okay, so this is one equation. We've sorted only one equation so far. Now, a good idea would be to write it nicely. Okay, so I'm going to do that. 3 minus mu is equal to minus 1.329 sigma. Okay, so 1.329 sigma minus mu equals to minus 3. So here's one equation. Okay, any questions so far? Okay, great. Now, how do you find out inverse using a calculator? Once again, go to 7, go to distribution, but this time don't select normal cumulative distribution. Instead, select inverse normal. Okay, instead select inverse normal. Now, the area under the z table, which has mean 1 and which has means of 0 and standard deviation 1. What is the area equal to? The area is equal to the probability.
The probability.
That's correct. Okay, now what's the probability here? 0.092. Okay, so 0.092. So you write 0.092, let the mean be, let the standard deviation be 1, let the mean be 0, and then you'll notice that you get minus 1.3285, which is as good as minus 1.329. Okay, that's how this works. That's how inverse works. Okay, now what do we do when it's greater than? We'll have a look at that also. Okay, we'll have a look at that. So here's the first equation. Now let's set up the second equation. So once again, if you had to find out the z-score of 8, here's how you would do it. 8 minus mu upon sigma, okay? And the probability of z being greater than 8 minus mu upon sigma is equal to what? Is equal to 0.19, okay? Now, what do you do when you're finding out the probability of greater than? Here's what you do. You do 1 minus phi of the z value. Okay, 8 minus mu upon sigma, or phi of z score, which is equal to 0.19. Why? Because remember, you're finding out greater than. Okay, so let's do 1 minus 0.19. 1 minus 0.19. So what's that equal to? That's equal to 0.81. That means 0.81 is equals to phi of 8 minus mu upon sigma. Okay. Now, if we take phi across the equals to sign, it becomes phi inverse. Now, see if you guys can find out phi inverse of 0.81 using your calculator, so I can make sure that you've understood how to do it. Go ahead and find out phi inverse of 0.81 for me. Okay, not minus. Okay, it's going to be positive. Yeah, 0.878, but it's going to be positive, not negative. So 8 minus mu upon sigma is equals to 0.878. Once again, let's cross multiply. Let's write this nicely. So 8 minus mu is equals to 0.878 sigma. And if you write this nicely, this becomes minus 0.878 sigma minus mu is equals to negative 8. Okay, so the reason why I've written them like this is so that I can use my calculator to solve it. 1.329 sigma minus mu is equal to minus 3. So here are the two equations. Let's solve them simultaneously using a calculator and see what we end up with. So simultaneous equation with two unknowns, minus 0.878 minus 1 minus 8, 1.329 minus 1 minus 3. So sigma turns out to be 2.265, which means 2.27, and mu, the mean, turns out to be 6.01. Let me see if that's the correct answer. 2.27. Yeah, that is the correct answer. So there you go. That's it. Job done. So this would be classified as a pretty difficult question. Okay, we're not going to classify this as an easy question because there's a lot of working that's involved, a lot that can potentially go wrong. So if you can do questions like these, especially the kind of questions where you have two unknowns, then that means you've gotten comfortable with normal distribution. That means you have a good grip on normal distribution. And I don't know honestly why people make a big deal of normal distribution. It is tricky, it's lengthy. Yes, there's a lot that can go wrong, but it's not that difficult once you understand what the question is asking for. How do you guys feel? That's my opinion. I could be wrong, but what about you guys? So my answer is going to be rounded off to wrong significant figures. Okay, that's something you can fix. Okay, if your rounding off is incorrect, that's something you can fix. Okay, that's not that big of a problem. Okay, but generally, how do you guys feel about normal distribution? Still find it difficult? Lengthy but easy. Yeah, lengthy, but it's pretty straightforward. Okay, it's pretty straightforward. Like there are no exceptions. Like wait a minute. In this case, we're not going to treat it like this, or in this case, we're not going to treat it like this. Generally, you'll find that with statistics. You won't find a lot of exceptions. Okay. All right. Now let's see. Yeah.
Can you explain the part जहाँ पे आपने वो minus से multiply किया है?
So basically, मैं समझा देता हूँ, and I'll refer to the note also that we have written. Yeah, okay. So basically, here we had to take phi inverse of 0.25. That means we had to read the table, but we had to read it backwards. Okay. Now, there's no way we can find the inverse of 0.25 because the values start from 0.5. Okay. Now, in that case, what do? The value that we're supposed to find the inverse of, we subtract it from 1. And either we can multiply the other side of the equals to sign by minus, or the value that we get after reading the table backwards, that means the probability, we can multiply that by minus. Okay, so that's what I've done over here. Earlier I did it slightly differently. In this question I did it slightly differently. Reason is so that you guys are aware of both the ways. Okay, so if you can't find inverse of value, it's really small, no problem, subtract it from 1, and then in the end, remember, the price that you have to pay for that is that you have to multiply it by minus. Okay. All right. Now comes part C. Sir, can we solve equations simultaneously on calculator? Do we have to? Dekho, just write down the two equations. Okay. Write down the two equations, and then you can write the final answer. Okay. Write down the two equations, and then you can write down the final answer. That's fine. Okay. Nothing.
Could you show the answers for the B part?
Yeah, sure. Here they are, 2.27 and 6.01.
Okay, sir.
Okay, then comes part C. Part C says, in a random sample of 2000 leaves of this second type, how many would the scientists expect to find with lengths more than one standard deviation from the mean? Okay, more than one standard deviation from the mean. So, how many leaves are we talking about? We're talking about 2000. How do we do this? Any idea? What is more than one standard deviation from the mean?
Then 1, I mean, if mean is 0, then the standard deviation must be like greater than 1.
Okay. Now, more than one. All right. Does it mean greater than one or lesser than one?
Like greater than?
Okay. Think about it. देखो, the way that we have a bell curve, okay, the way that we have a bell curve, it's not saying greater than, okay, it hasn't exactly given you a value, okay. So here's how this works. So this is the bell curve that we have, okay, this is the bell curve that we have with mean 0, okay, and this is basically representing the z table, okay. So the z table has values which has mean 0 and standard deviation 1, okay. Now if I ask you this question, how far away is this value from the mean, or how many standard deviations away is this region from the mean? How many standard deviations away is this region from the mean? What would you say?
Sir, 1.
You would say 1 standard deviation, okay. 1 standard deviation, okay. That means this area is representing more than 1 standard deviation away from the mean, okay. What would you say about this? How far away is this from the mean? How many standard deviations away do we find this from the mean?
Sir, -1.
Okay, how many standard deviations? We don't say -1 standard deviation, we say 1 standard deviation. So this also is 1 standard deviation away from the mean. Okay, that means this area is representing the probability of the values being more than 1 standard deviation away from the mean. So that means it's not just this, it's this as well as this. Okay, that means you have to find out in part C, you have to find out the probability of z not just being greater than 1, but you also have to find out the probability of z being less than -1, because both these regions are representing the values that are more than 1 standard deviation away from the mean. Okay, both these regions are representing the values that are more than 1 standard deviation away from the mean. Okay, I repeat, here's the mean, 1 is the standard deviation, okay. So this region is representing all the values that are more than 1 standard deviation away from the mean. This region is also representing all the values that are more than 1 standard deviation away from the mean. The difference is that here, in this we add, in this we subtract, okay. But both these values are more than 1 standard deviation away from the mean, okay. So what we have to find out, the probability of z being greater than 1 and the probability of z being less than 1. Okay, now there are two ways that you can go about it. You can first find the probability and then multiply it by the number of leaves. That means you can first find out you can use the z value, okay, you can use the z table to find out, or what you can do is you can first find out the two ranges. That means the mean, using the mean, which is, we worked out the mean 2.27 or 6.01. okay, so here's what you can do. You can find out the probability of x being less than 6.01 plus 2.27 or greater than 6.01 minus 2.27. Okay, so that way what you would have to do is you would have to first convert your x to z. Here what we're doing is we'll use z and then we'll convert it back to x. How? I'll show you in just a minute. So probability of z being greater than 1 plus the probability of z being less than minus 1. Why are we doing this? Once again, because we have to find out how many of these 2000 would the scientists expect to find with lengths more than 1 standard deviation from the mean. Okay, so remember we're talking about 2000. What we're doing right now is just for 1. Okay, since we're using the z table, we're finding it out just for 1. Okay, and then depending on the number of leaves that we're talking about, we'll multiply it by that. Okay, so the probability of z being greater than 1, how will we work that out? We'll work that out by simply doing 1 minus phi of 1. Okay, and then how will we work out the probability of z being less than minus 1? We could take simply phi of minus 1, but we can't do that. Okay, we can't take phi of a negative value. So instead what we'll have to do is we'll have to do 1 minus phi of 1.
Sir,
Yeah.
say we could like also multiply it by 2, right? Because they're same areas.
Yes, we could multiply it by 2. Okay, but that is something that you would probably figure out after you make the diagram. Okay, that's correct. You could simply multiply it by 2. You could find out the probability of 1 and then multiply it by 2. Okay, so we basically are able to confirm this by simplifying this. Okay, by simplifying this you can confirm this. So this becomes 2 minus 2 phi of 1. Okay, so let's find out phi of 1. Let's see what do we get. Phi of 1. Phi of 1 means 1.0, which is 0.8413. Okay, so 0.8413. So this becomes 2 minus 2 of 2 into 0.8413. Okay, now remember, this will give us the probability of one leaf. Okay, what we are supposed to do is we're not supposed to find the probability, we're supposed to find out the number of leaves. Okay, we're supposed to find out the number of leaves. So this gives us 0.3174. Okay, so 0.3174 is the probability of one leaf. So since we're talking about 2000 leaves, what do? We multiply it by 2000. So multiplied by 2000, what do we get? We get 634.8. Okay, and which if you round off, you get 634. You're not rounding it off over here. Basically, we find 634 leaves, which will be more than 1 standard deviation away from the mean. Okay, now this is one way of solving it. The other way would be using the x values. So here we use the z values. Okay, since we're given the standard deviation, and z score, remember, represents standard deviation only, standard deviation from the mean. So another way of doing this would be to use the x values. Okay, now the mean is 6.01, so 6.01 plus 1 standard deviation, this is also 1 standard deviation away from the mean. The other would be 6.01 minus 2.27, this is also going to be 1 standard deviation away from the mean. Okay, so that means we could do this. We could do 6.01 plus 2.27, that is 8.28. But you'll notice that you'll realize in a minute why doing this is absolutely irrelevant. And it's okay if you do it in the exam. Okay, nothing to worry about, because in the exam you're not thinking of the best possible way, you're just thinking of how to solve the question. So here's what you're going to do. You're going to work out, let's call this z1, and you're going to work out z2. So let's start with z2. When you work out z2, 8.28, we know already how we got 8.28. We got 8.28 by adding 1 standard deviation to the value of mean. Okay, and remember, your z value tells you what? Your z value tells you how many standard deviations away it is from the mean. So what do you think the value of z is going to be over here? What do you think we'll get as the value of z if you work it out?
1.
We'll get 1, exactly. And then similarly, if you find out z1, for which you will do 3.74 minus 6.01, so whatever you added, you're now subtracting it again, divided by 2.27. So what is this going to be? This is going to be minus 1. Okay, so remember, every time we're finding out the z value, we're finding out how many standard deviations away it is going to be from the mean. Okay, the mean is considered as 0. Here, since we're already given how many standard deviations, That means we're already given the z value, 1 and minus 1. Okay, so then this would result in the probability of z being greater than minus 1, less than 1, which you would do it the exact same way. Phi of 1 minus phi of minus 1. This is how you do it. Okay, now any questions? If yes, feel free to ask.
Say we're like rounding, so we round down always the answer, right? In all distributions.
Dekho, no, don't. Acha, yeah, I just realized that this is not actually what we were supposed to do. We're not supposed to find out in between. We're supposed to find out more than. That's why I erased it. So we're supposed to find out probability of z being greater than 1 or the probability of z being less than minus 1. This is what we're supposed to do. Yeah, now coming to your question. Dekho, it depends on the context of the question. We don't just make a blanket rule and always round down. If, let's say, notice what the question says. The question says, how many leaves would the scientists expect to find with lengths more than 1 standard deviation from the mean? Even if it's 634.99 leaves, what is the distinct number of leaves that he finds? It's still 634 because the 0.9 doesn't make sense. Okay, so that's why what we're going to do is we're going to round down. It's like, think of it this way. Let's say something is only sold in integer quantities, okay, and you have just enough money to buy 5.7 of them. Okay, now unless you get a good deal or a discount or a bargain or something, then yes, you can purchase 6. But if something is sold in integer in distinct units only, you can only buy 5 of them. Okay, that's the logic that we're applying over here. Although I'm pretty sure मार्किंग स्कीम में थोड़ी सी फ्लेक्सिबिलिटी होगी इसमें. ठहरो, let me check. It's May June 2022 paper. Do you understand the concept?
Yes, sir. So like it depends upon the data, like if it's continuous or it's discrete.
Yeah. Since we're talking about leaves, that means it has to be discrete. Okay. So it's May June 2022 paper 51. I'm sure थोड़ी leniency होनी चाहिए marking scheme में. एक value की बात है. Let me check. Yeah, okay. So thankfully, the examiner is slightly lenient over here. 635 will be accepted, okay? But logically, it's going to be 634 only. Okay, not 635. Okay, now let me give you guys a question to solve. Okay, see if you guys can do this. Normally it's the within or these many standard deviations away from the mean that students mess up in. Okay, so go ahead, see if you can solve this question. And I hope we didn't do this question in class. Taro, let me just quickly check.
Sir, I think we did it. Someone asked it on the chat.
I think I explained it on WhatsApp, but I don't think we
Yes, sir.
solved it. Actually, wait a minute. I have this question and I don't think. So this was in the homework. Yeah, this was in the homework. Okay, koi baat nahi. Let's pick another question. Let me pick a really old question.
Sir, could you also solve the homework questions that you gave yesterday or probably?
Yeah, sure. Yesterday I didn't give you guys any homework, but I get what you're saying. Which question exactly? Can you tell me?
Sir, question number 24 and I think C part of the question 18.
Okay. Alright, first solve this question. Okay, so do we have the answer? Mu for the answer for the first part. Now I'll do some working as well, so you guys know how to do it. So this is what we're going to use. The probability of x is less than 6.8 is 0.75. That means the z-score will be equal to 6.8 minus mu over sigma. Okay, now we're given that sigma is 0.25 mu. So 6.8 minus mu over 0.25 mu. Okay, so the probability of z being less than 6.8 minus mu over 0.25 mu is equal to 0.75, and since it's less than, that means the phi of 6.8 minus mu over 0.25 mu without subtracting from 1 is going to be equal to 0.75 only. And then if you solve this, you get the value of mu to be 5.82. Okay, and then for part 2 you have to find out, now not only will you be able to find out the value of mu, you will also be able to determine what sigma is. So sigma will be what sigma? Anyone who's worked out the value of sigma, the standard deviation? 0.25 into 5.82. 1.455. Yeah, 1.455. So using that, you will be able to find out the probability of x being less than 4.7. Okay, so these two parts are fairly easy. That's not what I'm interested in. I'm interested in whether you guys can solve part B or not. And also, Shayan, you can use your calculator as well. Don't forget to do that. 0.75, mean 1, standard deviation 1, mean 0. Yeah, you get 0.674. Okay, I'll solve. The lengths of metal rods have a normal distribution with mean 16 and standard deviation 0.2. So mean is 16, variance 0.2 squared. Okay. Rods which are shorter than 15.75 or longer than 16.25 are not usable. Okay, are not usable. Find the expected number of usable rods in a batch of 1000 rods. Okay, so that means probability of x being less than 16.25 minus 15.75. These are not usable. Okay, तो अच्छा कैलकुलेटर से भी इसको क्रॉस चेक कर लेते हैं. Whenever you have a range, it's easy to work it out in a calculator. So the lower is 15.75, the upper is 16.25, the standard deviation is 0.2, the mean is 16. So we get 0.788. अच्छा, ये हम usable निकाल रहे हैं, by the way. ये जो हम निकाल रहे हैं ना, because it says longer than 16.25 are not usable and shorter than 15.75 are not usable. तो usable कौन से होंगे? Usable ये होंगे जो कि इनके बीच में आते होंगे. Okay, I'll repeat what I said. The rods that are shorter than 15.75, that means x is less than 15.75, not usable, and at the same time, if x is greater than 16.25, this is also not usable. So the question is, what are usable? So if you make a number line, it will make more sense. Yeah, you were saying 15.75, 16.25. So anything.
So I did with the second probability.
Oh, okay. So anything greater than 16.25 and lesser than 15.75 is not usable. That means what's usable are the values that are in between. These are what's usable. Okay. So if you do this, you will end up basically calculating the probability of usable. Okay. So how will you do this? First you will find out, let's find out the two z values. Let's call it z1 and z2. Let's start with z2, 16.25 minus 16 over 0.2. So 16.25. And by the way, the calculator is giving the direct answer as 0.788. So make sure to check your answer. Divide by 0.2. So this is 1.25. So z2 is 1.25. And let's find out z1, which means this is also going to be 0.25 1.25 except I think it's going to be negative. 15.75 minus 16.25, yep, minus 0, divide by 0.2, that's minus 2. Wait a minute, 15.75 minus 16, sorry, 15.75 minus 16 divided by 0.2. Yeah. So symmetrical are here. Z1 is equal to minus 1.25. Okay, now a good idea would be to first map on the curve what we want, so it's easy for you to find out the probability. So you understand what it is that you have to do. So you have to find out the probability of basically this region. This region right here. Okay, this is 1.25 and this is minus 1.25. Okay, 788 or 789. Yes, 788, 789 is the correct answer. Okay, so how do we do this? Here's how we do it. First you find out phi of 1.25. Okay, but the problem, and from this you subtract phi of minus 1.25. But we know very well there's no such thing as phi of minus 1.25. So for this we do phi of 1.25 only. Okay. So altogether this becomes what? Altogether this becomes minus minus plus. So 2 phi of 1.25 minus 1. Okay. So let's work this out. Phi of 1.25. See what do we get? 1.25, here's 1.2, 1.25 will be 0.8944, okay, multiplied by 2 and then minus 1. 1.25, 0.8944 multiplied by 2 minus 1, so we get 0.7888, and then that's the probability of 1. Since we're talking about 1000, don't forget to multiply it by 1000, okay. So 0.7888, that's the probability of 1. Since we're talking about 1000 multiplied by 1000, so 788 or 789 is the correct answer. So once again, not too difficult. Yes, lengthy, I know it can sometimes be a pain, questions like these especially, but not too difficult. Once again, no exceptions really. Okay, pretty straightforward questions. Okay, now let's discuss the homework related questions that you've asked. Okay, and once again I would strongly urge you guys to please keep practicing normal distribution. In any paper, normal distribution will easily be a question of 7-8 marks at least. Okay, could be more than that. So you really want to make sure that you have every concept of normal distribution sorted out. Okay, all right, so 18 part 3, is that correct, Shaihan?
Like the whole question.
The whole question? Okay, let's do the whole question then. Okay, let's see what it says. So it says eggs are sold in boxes of 20. Cracked eggs occur independently and the mean number of cracked eggs in a box is 1.4. Okay. Calculate the probability that a randomly chosen box contains 20 cracked eggs. Okay, how do we calculate the mean? If you remember, mean is calculated by doing n into p. याद है? Mean.
तो यही मसला था, वो मुझसे सब मीन ही कैलकुलेट होगा था.
Okay, चलो अब तो हो जाएगा. So 20 into p equals to 1.4. So p is equals to 1.4 divided by 20. So that is 0.07. Okay, so this is the probability of a cracked egg. Now you can find out the probability of not a cracked egg. That's going to be
सर हम लोगों ने मीन ज्योमेट्रिक का एक पढ़ा था ना 1/p, वो ज्योमेट्रिक है राइट?
1/p हाँ ज्योमेट्रिक का है, यस.
और ये वाला से बाइनोमियल का.
ये वाला नॉर्मल का है. अच्छा, ये सवाल आपका बाइनोमियल डिस्ट्रीब्यूशन का था ना? हाँ. So we did this formula yesterday only. We did this formula yesterday only. No, not yesterday, I mean in the last class, last normal distribution class that we had, or basically in the class of normal distribution. I don't remember when exactly, but that's when we did this. So remember we saw the conditions. Yeah, so mean is n into p. Okay, mean is n into p, and the variance, not only that, you can also find out the variance. Variance is npq. The variance is NPQ.
Yeah, but ये वाले formulas हमारे उसके लिए नहीं, like conversion from binomial to normal.
अच्छा देखो चलो एक काम करते हैं. We did this yesterday. The conversion part we did it yesterday. Okay, if the conversion part we did it yesterday, then I think I gave you this homework sooner than I should have. अच्छा अब एक काम करो देखो. There's another way that we can do this. Okay. If in a bag of 20 eggs, okay, eggs are sold in boxes of 20. Cracked eggs occur independently, and the mean number of cracked eggs sold in a box is 1.4. Okay. Then technically, what do we have? We can still find out the probability. Let's say we're not aware of the formula. Okay, we can still find out the probability. If I want to find out the probability of cracked eggs, what do I need? I need the total number of eggs, okay, and I need the number of cracked eggs. Do I have that? Yes or no?
Yes, sir.
Yes, we do. So technically, वही formula बनता है. Okay, favorable upon total. Okay, favorable upon total. So what's the number of cracked eggs that we have? 1.4. What's the total number of eggs? That's 20. So 1.4 divided by 20. That again gives you 0.07. Okay, so P is equals to 0.07. That means Q is equals to 0.93. Okay. Now, do you want me to solve this question further?
No, sir. वो मुझे फिर समझ आ गया.
I was confused as well whether we use. So 1.4, since 1.4 is like, think of it this way. I think the word mean makes it confusing. What if I put it like this? That in a box of 20 eggs, the average number of cracked eggs are 1.4. Okay, now can you find out the probability? If you just change the wording slightly, it becomes easier. That means now we know the favorable outcome is approximately 1.4 and the total is 20. So 1.4 divided by 20 makes it easier. Achha, what other question did you ask?
सर मेरा एक सवाल, मतलब सर ये वाले formulas अगर हमारे normal के, so why are we like using it in the binomial?
देखो, we're technically not. Okay, we're technically not using the formula, and the thing is, yes, this formula is applied to binomial to normal distribution only, but it's not like this formula is just relevant for normal distribution only. This formula can be applied anywhere. See, technically the formula, even if you ignore this formula for a minute and you just talk about calculating probability. So what's probability? What will be the probability of cracked egg? The probability of cracked egg would be the number of cracked eggs. Okay, the number of cracked eggs divided by the total eggs. ऐसे ही होगा ना?
Yes, sir.
अब what are the number of cracked eggs on average? On average, in a box, the number of cracked eggs that you find are 1.4. Okay, 1.4 divided by the total number of eggs, which is 20. This gives us the probability of cracked, which in this case is equal to P. Okay, so what is that equal to? P is equals to 0.07. अब normal distribution में भी जो formula आता है ना, वो भी यहीं से आता है. It's not like in normal distribution we're dealing with something completely different. We're still dealing with probability. Okay, the only difference is that here we refer to as cracked eggs as the favorable outcome. We refer to it as the mean of the favorable outcome. Okay, or we say simply the mean. That's why the formula becomes P is equals to mu over n. Okay, and then if you cross multiply, mu is equals to np. Okay.
Okay, sir.
That's the connection. Acha, sir, I had a Acha, Shahan, you asked another question. I'll take that question, and then I'll take your question as well.
24, question number 24.
Binomial?
Yes, sir.
Okay, let's see what it says. In a certain...
Just wait a minute, sir. I think I got the question wrong. Just let me check once.
Maybe it was 24 of normal distribution. No, this is binomial. Where is normal? Here is...
Sir, could you just show the answer sheet of these questions?
Sir,
Sir, yes, question number 31. Sorry, sir.
31? Okay.
Yes, sir.
31 मैंने पहले भी कहा था. In the last class I said that don't do 31 just yet because it involves use of permutation and combination. I think you hadn't joined then. Yeah. So somebody else asked me question number 31, so I said don't do 31 because I realized that it involves a bit of use of permutation combination. That's
ठीक है
all.
सर.
ठीक है.
सर मैं उसको ही मैंने अप्लाई करने की कोशिश की थी लेकिन तब भी नहीं हो रहा था. मतलब मुझे ये चीज़ नहीं समझ आई थी जो हम उस पर कम करते जा रहे हैं ना 12, 11, 10
अच्छा.
हाउसेस को.
The 12 houses on one side of a street are numbered with even numbers starting at 2 and going up to 24. A free newspaper is delivered on Monday to 3 different houses chosen at random from these 12. Okay. Find the probability that at least 2 of these newspapers are delivered to houses with numbers greater than 14. Okay, काम करते हैं. Let's do this after we do permutation and combination only. Okay. उसके
Okay,
बाद
sir.
ही हम इसको कर लेंगे. अच्छा, then Ahnaf, I'll take your question. October, November 2020. Paper 53. Question number 1B. Okay, this one. 13% of the members. I think we've done a question similar to this. Or maybe this exact question. Okay, I'll solve it. But can you confirm this is the question? There seems to be a catch. Okay, let's find out what the catch is. 13% of the members of the club take more than T minutes to swim 100 meters. Okay, so we're talking about the distribution of 100 meters. The time taken to swim 100 meters, which is a normal distribution, mean 62, and variance 5 squared. Okay, so the probability of x being greater than t is 13%, which means 0.13. Okay, now how will I find out the z-score of t? Here's what I'll do. T minus 62 divided by the standard deviation, which is 5. Okay, this will give me z. Okay, that means the probability of z being greater than t minus 62 over 5 equals to 0.13, which, and since it's greater than, that means we'll have to do 1 minus phi of t minus 62 over 5, which is equal to 0.13. Okay, now what's 1 minus 0.13? 1 minus 0.13 is 0.87. So 0.87 is equal to phi of t minus 62 upon 5. So I don't think there's any catch. Let's find out the inverse of 0.87. I'll use a calculator to save some time. So area is 0.87. We get 1.126. 1.126 is equals to t minus 62 upon 5. So cross multiply into 5. 1.126 into 5 plus 62. So 67.63. That's what we get. 67.63. Is that not the correct answer? Oh, I know what the catch is. I'll let you figure it out. Okay, see if anyone else can answer it. The answer that we're getting is 67.63. The correct answer is 1.13. I'll take you guys back to the question, and the rest of you, see if you can tell me why that's the answer. I'll zoom out enough so you can see. It's more like an O-level standard catch, O-level or IGCSE standard catch. Yeah, 1.13. Read the question. And let me know when you give up. Although you shouldn't, it's pretty easy to identify. Still no? Still haven't figured it out? Enough? Yes, thank you. We have to convert seconds to minutes. Okay, what we have worked out is basically seconds. Okay, why is it seconds? Because the mean is in seconds and the standard deviation is also in seconds. Okay, so this 67.63 that you're looking at is the value of t, is the correct value of t, but it's in seconds. So how do we convert this to minutes? How do you convert seconds to minutes?
So divided by 60.
Divide by 60. So divided by 60 and half, you will get exactly 1.13. I know. Happens. See, the thing is, you're not really expecting these kind of catches in S1. You know, these kind of catches you expect in O levels and IGCSE. So I understand. But having said that, keep your eyes and ears open. Okay, so once again, I would strongly encourage you guys to start practicing normal distribution. Not start practicing, but to practice normal distribution, binomial distribution, and geometric distribution. These three distributions, honestly, they're not that difficult. And like I said, they can be lengthy, but not difficult. Okay, so these are easy marks. Okay, and I will be testing you guys on all three distributions in the coming week. Okay, so I'm giving you guys a week-long heads up. The test will not be during class hours. Okay, it will be on a separate day or a separate time, maybe on the same day but separate time. You'll have the entire day to give it, but please make sure that you give it. Okay, so there will be a test including all three distributions. All right, I'll announce it officially in the group as well, but I'm letting you guys know right now also. It will consist of binomial distribution, geometric distribution, normal distribution. And I'll also give you a hint: focus on the questions where the question starts with binomial and then takes you to normal. Okay, so focus on those questions especially, because that way you'll end up practicing binomial distribution along with normal distribution along with continuity correction. Okay, continuity correction, once you're doing a lot of normal distribution questions, you forget to apply, so just make sure you practice those questions where you have to apply continuity correction. Okay, so I will stop here. I'll see you guys inshallah in the next class where we start permutations and combination. Okay, so that's it. Take care everyone. Allah Hafiz.